Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled RLE Encoding and Elliptical Curve Cryptography for Enhanced Security of IoT Data. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the security protocols that we have designed for data communication in the IoT and using the IoT server ThinkSpeak for updating the data by proposing the RLE and ECC based encryption method. So this is the multi-level encryption method. So this encryption method can be implemented in the real-time scenarios and further research can be done over that. So let's talk about that, what exactly we have done into this video and what we will cover into it. So in this video, initially we will talk about the application areas where it can be realistically used, then whatever the code we have designed, how to execute it, and what are the software requirements. Along with that, we will talk about that what are the current systems those are working in the same domain and what problems we identified and that helped us to propose the methodology. Finally, the experimental outcomes and findings will be discussed. So let's talk about the application areas, as it is basically an encryption methodology for the data specifically designed for the IoT. So it is not only restricted to the IoT networks, even it can be used anywhere where the communication and the data transmission or any of the information is to be transferred. So this is related to the internet security, even for the digital security, network security, and the data protection. In all those scenarios, the developed system can be implemented. So now let's talk about the code that we have designed. So we will give you the folder named code under which all the files has been placed. So in order to run this, we must have the MATLAB software with us. So the MATLAB version that we are using is 2019A. You can use 2015 or the higher version, but make sure it should not be a trial one, it should be the full version. So to run the code, you just need to go to the folder where the whole code is placed and just copy the path of the folder. Go to the MATLAB and just paste the path here and press enter. When you will press enter, all the files will be shown here. Out of that, you just need to run the main code because all other three files are the functions. Those are called in the main file. So in order to run this, you just need to go to the editor window, which is by default when you will open this code, and here is the run option. There are two sections in the run option. You just need to click on the green button. When you will click on the green button, it will start executing the code and the whole code will be executed. Now let's talk about what are the current system and what were the problems identified. So there are certain applications, those are working on developing the systems, those are giving the security to the data. So one of the system that we were analyzing was efficient method for security management in Internet of Things. They have proposed one of the method under which they were giving the hybrid encryption algorithm. In that, they were using two of the methods. One is AES and another one is NTRU. AES is a very much effective technology for the in the domain of the encryption, where the basically it is used for the key generation because it is very effective. But NTRU is effective, but it is an open source, it is a very complex system. So these are the issues that we have identified, because if we are going to improve the NTRU in any of the scenario, then because it is an open source, daily updations are there, so it cannot be expected that the systems can give us the effective outcomes even after the modification. So there should be a stable model and must be a less complex system that can provide us the effectiveness in the data security. So the proposed methodology that we have designed is basically the two-level encryption and the security, where initially we are providing the data security by encoding the system in order to reduce the data size. Secondly, we are applying the encryption methodology along with the AES key generation and ECC to provide the security to the data. So one, encoding, that encodes the data, that helps in reducing the data as well as converting it from one form to another, which is also a type of encryption. Secondly, AES and ECC based encryption, which is additionally providing an encryption data. that helps in providing the multi-level of encryption. So here you can see what we have done, the main contribution I just told you. Secondly, what we did, the MathWorks ThinkSpeaks networks has been used, where the data can be uploaded and can be seen remotely in the encrypted form. So what we have done, we have just designed the system. In order to run this code, you just need to click here, it start processing. You can see the whole system has been processing and giving us the results. So let's see what we got. In the initial stage, we are showing that how much time the AES was taking for the data pre and post processing, and what the expected results those we have achieved from the proposed methodology. So Han was giving the less time, but because of the complexity and the methodology they were using, dual security is not provided, where our system is providing the better results, and in terms of the AES and other like less complex two level of the method encryption, so it is expected to be the better outcomes. Here the compressed data set, this was the actual data, and when we have applied our technique, you can see that data get encrypted of the two level, as well as the size of the data is also reduced, which is very crucial for the networks to transfer over the network, so that the space can be saved, it cannot be easily decrypted. Then next to that, this is the post compression data size. When the compression has been done and data is processed further for the encryption, you can see this is the information related to that. Finally, the data is also shown in the different scenarios for the different packets. This is for packet 1, 2, 3 and 4, and lastly this is for the after the compression of the 4 packets. And finally, the results that we have achieved was this was a standard deviation and the variation of the proposed method, that how much variation is there among the data. So you can see the standard deviation and the variation that we got in our system is higher, which is very much effective in the scenario. So the data has been generated, RLE encoding is applied at the initial stage. When the RLE is encoded, then we are generating the AES key by using the AES methodology, and further ECC encryption is being applied by using the key generated by the AES. So on that we have the ECC is encrypting and giving us the results. And finally we have calculated the compression ratio of the initial stage and the proposed methodologies, and then showed the result in different scenarios, like how much time it take, along with that the compression of the data size, post compression data, and the finally packets represented as compressed and the actual one. And finally the decryption is also shown, and we have checked that how much variation is there among the data. So you can see the after the decryption, the data is having least error. So you can see this was the error we have calculated, MSC, it is 0. It means whatever the data we have encrypted by using the proposed method can easily be decoded at the receiver end. Now ThinkSpeaks server. So ThinkSpeak server, this is the part that we just commented, because we need to show that how it can be done. So basically ThinkSpeak is an platform provided for the IoT surveillance by the MathWorks company, whose tool MATLAB is there. So you just need to open this link, api.thinkspeaks.com, and you just need to go there. You can create your account if you are not having along with you. So it is taking some time to get open, so you can just google it, ThinkSpeaks. So here is the model, so you can just click here. When you will click here, this kind of more page will be there. So you can just click over the sign in here, or directly the sign in button can be here. Here you can give the details of the account that you are already having with the MathWorks. So you just need to create by clicking on the create one. So when you will click on the create one, here you just need to give the email ID, the country where you reside, your name and the last name. When you will click on the button, let's say I am giving an email, it can be any, so first name and last name. Later on when you will fill the further continue, so do the login process. When you will log in, let's see how the page will be shown. So when you will log in, the page will be like this. So in order to create the new model, you just need to click on the new channel. When you will click on the new channel, I just need to delete it because already there is one with me. So let's say I'm using this, I need to delete it. In order to delete it, I just need to go to the section. Here you can see. So this was my current system which I was using, where I've created the fields. I just need to show you that how you can create a channel. Let's say air monitoring is there, I just need to delete it here. Then in order to channels, my channels, how I can delete. So go to the channel settings, then delete channel. So here is the option delete channel. I'm deleting it. So now creating one of the channel for you. When I click on that, you just need to give the name of the channel, for example test channel, and then if you want to give the description, then it is okay, else you just need to select the fields. So at maximum of the 8 fields can be given. So in our scenario, the data we are generating, we do have the required 2 different channel, one to save the key, another to save the data. So the data need 8 fields. So you just need to select a total of 8 fields. You just need to click here, 1 2 3 4 5 6 7 and 8. So for the keys we need the lesser one. So after, once you will give this labels, you can change the name. I'm not changing it right now. Rest you need not to change anything. Just click on the save channel. When you will click on the save channel, you can see all the individual data entities can be seen here once it will be further processed. Now in order to process it in the MATLAB code that we have designed, you just need to go to the API keys. Then in the API keys, if you want to write data to it, then you just need to use this key. Else if you want to read it, then you need this. In our scenario, we need to send data from the MATLAB software to the server, so we need write key. So go to the page and get the write key here, or you can directly get the link from this. You can see this is quite similar as I have already written over here. So you just need to copy it, or you just need to copy the key. This is the key basically, and you just need to paste it here. Here I have mentioned your key. In this much part you just need to paste your key. This is the sample that I have given. So from and to the further, this is the further whole link of the data transmission, and here up to your key you just need to paste that key. Let's say I'm doing the copying the key, so I'm just copying it here, going to the MATLAB, and here I am pasting it. So when I'm pasting it, when it will process the code, it will update the data that is generated from here. So let me show you. I'm just uncommenting it, control T to uncomment, and just writing it here so that only one entry can be updated. So I just wrote the write key here. Rest all the data, because the data is of 8 lengths, so 8 fields are there. So when I'm running for once, let's see if we will get the data updated over there, which was initially not there. So coming back to the view, you can see those who were already blanked now must have the data with us. So let's see if we didn't get any comment. So here is the API key update. This error is because I just wrote this. So let's reset it. So if I'm running it again, let me see if I'm missing something about any server details. No, it is okay. So I'm rerunning it. Browser, hit it, and let's see if we get the results here. When I'm running it, see the entries are updated here. It is just 1836. So you can see here 1836. In every of the field we get one of the entity. That is the data that we got here. Here you can see, I can show you what data it is. For example, here it is 6976726.488. Let's see, is it actually the same data that I was sending? Here the data. So let's see that. So you can see this is 6.926. So this is the data that is uploading to here. So that what we did in order to save the data over the network, in order to show that how the system can initiate it. So in order to see the further things, you can just rerun the code continuously without giving any of the restriction here. So it will run. So I'm again recommenting it so that it can be run without system. So make sure your system should be connected with the internet so that it can hit that link and upload that data whatever we are sending. Only you need to change this key, your key. So whatever the key you will generate over the channel, that you need to see. Again showing you where you need to go. You just need to create the channel. After creating the channel, you just need to go to API key and can get that particular key or a direct link from here to here. This is only for field 1. We need to write for all the 8 fields. So that what I have written in the code. So Further modifications are still possible into it. For that, you can directly contact us, and for industrial applications designs also we are assisting. So thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.